Hi. Today we're going to talk about the basics of probability for 7th grade math, particularly focusing on simple probability. First up, some vocabulary. Probability is a number from 0 to 1 that describes how likely an event is to occur, with 0 being the least likely, 1 being the most likely. So if we have a penny here, the probability of landing on heads when tossing the penny is 1/2 because there are two options, heads or tails. And if we wanted to land on heads, that's a chance of 1 out of 2 opportunities. The outcome is a possible result of a probability experiment. So when rolling a number cube, rolling the number 3 is one of the possible outcomes. An event is an outcome or set of outcomes of an experiment. So for example, when rolling a number cube, the event of an odd number consists of the outcomes 1, 3, and 5. A simple event, which leads us to simple probability, is just the event consisting of only one outcome. So for example, when you're rolling a number cube, the event consisting of the outcome of 3 is the simple event. An experiment is any procedure based on chance that can be repeated and has a defined result. So when we're working with probability to practice, we often use different types of experiments that are based on chance that can be repeated. For example, rolling a die, tossing a coin, picking a card from a deck, spinning a spinner are all examples. Other things like randomly selecting a colored sock from a drawer, or randomly selecting a child from a class. Different examples of experiments. The trial is the repetition of an experiment. So when you're tossing a coin in an experiment, each one toss is one trial. And then lastly, a sample space is all of the possible outcomes of an experiment. So for example, when rolling a number cube, the sample space is a 1, 2, 3, 4, 5, or 6. With flipping a coin, the sample space is heads or tails. When spinning a spinner with 4 likely chances, it's just spinning a 1, 2, 3, or 4. So let's look at some ways that we can work with simple probability. You will hear a number cube referred to as a die, a number cube, or if there's multiple, the plural of that is dice. So it's a cube with 6 sides, and each side has the numbers 1 through 6 on it. Example A says, what's the probability of rolling a 1? Well, on a number cube, there's one side with a 1 on it, and out of 6 possible sides for the number cube. So you would write that as a fraction, 1 out of 6, and if you wrote that as a percent, you would get 17%. Probability of rolling a 3 is the same because there's only one side that has a 3 out of the 6 possible options. Again, 17%. If you wanted to roll an even number and find the probability of that happening, there are 3 sides with even numbers, a 2, a 4, and a 6. So that's a 3 out of 6 possible chances, which simplifies to 1/2 or 50%. And if you wanted to roll a sum of 5 and find the probability of that happening, you would need to use 2 dice because you would need to find a sum. So you need to have at least 2 options to get a sum. So you could roll like a 1 on one dice and a 4 on another, or a 2 and a 3, or a 3 and a 2, or a 4 and a 1. So there's 4 chances out of 36 possible combinations, which simplifies to 1/9, which converts to 11%. You could also practice simple probability with a deck of playing cards. So just for some background on playing cards, a deck has 52 playing cards in it. There are 4 suits. Like you can see here, there are spades, clubs, diamonds, and hearts. Each suit within a deck has 13 cards. The ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. We want to find the probability of randomly selecting an ace. Since there are 4 suits and each suit has 1 ace, that is a chance that there are 4 possible outcomes, and 4 possible events with 52 possible outcomes. So you can write the probability as 4 out of 52, which simplifies to 1 out of 13. A heart, there are 13 hearts in a deck. So you would have a chance of pulling a heart 13 out of 52 tries, which simplifies to 1/4. If you were looking for the probability of selecting a red ace, so you would need it to be red, which would be the hearts and the diamonds. So there are 26 possible of those, but we need it to be an ace. That means there are 2 of those out of the possible 52 cards, and that simplifies to 1/26. Selecting the queen and finding the probability of selecting that queen, there are 4 queens in the deck, and so we would have a chance of 4 out of 52, which simplifies to 1/13. Let's do some practice. For example, your life is so boring that you've been on your phone the 3 of the past 6 hours. What is the chance you were on your phone in the next hour too? So we're using theoretical probability, basing your next hour on the past 6 hours of your time. So our time has been spent 3 out of 6. If we have that same chance, it's going to be 3 out of 6 or 1/2. If we convert that to a decimal, 0.5, and as a percent, 50%. You keep missing soccer practice, so coaches started you in only 1 game in the last 8 games. What is the likelihood of you starting in the next game? Basing it on our history, we are going to have to continue with that same probability of 1 out of 8 chance, which as a decimal is 0.125, and as a percent, 12.5%. However, luckily your coach lets you play, and you score 2 goals after 5 attempts. If you get to play the next game, and based on your performance, what is the probability of you making a goal in the next game to help your team? So basing it on that performance, you scored 2 goals out of 5 attempts. That's a 2 out of 5 probability. As a decimal, that's 0.4, and as a percent, 40%. So let's talk more about theoretical probability. Theoretical probability is the ratio of the number of ways an event can occur to the total number of equally likely outcomes. So if we were going to spin this spinner, in theory, that's what theoretical probability is, we could answer questions like, what is the probability of the spinner landing on a vowel? So in this spinner, we've got vowels A and E, and so we would be looking at a probability of 2 out of a possible 8 wedges on the spinner, and so we would have a 2 out of 8. Oops. Or 1/4, which as a percent is 25%. What is the chance the spinner will land on a consonant? So if we look at our spinner, we have consonants of B, C, D, F, G, and H. So we have 6 out of the possible 8, which simplifies to 3 out of 4, or 75%. Lastly, what is the likelihood of the spinner will land on a lowercase letter? If we look at the lowercase letters, we have 4 lowercase letters out of a possible 8. 4 out of 8 simplifies to 1/2, which is 50%. Now, let's talk about experimental probability, which is a little bit different than theoretical. This is, instead of saying, what if you spun the spinner, it is now saying you should spin the spinner and record your results. So experimental probability is actually doing the experiment. It is the ratio of the number of times an event actually occurs in your experiment compared to the total number of trials. So if you are following along, you can have this spinner, either draw it or you can use the printable that's in the attached PowerPoint, and use the paper clip and the tip of your pencil and spin the spinner 20 times. You can use a table like the one I have here, or again, if you are, there are some linked resources below that have this already made for you. And then you're going to record the frequency of the vowels, the consonants, and the lowercase letters, and then record those as fractions and percents. So pause this video right here and complete this trial on your own, filling out the results here. Then you want to compare and contrast the theoretical probabilities from A, B, and C in your experimental probabilities in the table. Likely, you got a little bit different results in your experiment than your theoretical probability. Why do you think this happened? It is because it was a small sample of spins. You only had to spin it 20 times, and that's not enough data to get really close to the theoretical probability. If you spun it 100 times, though, would the results be the same? Why or why not? The results should be closer to the theoretical because of a larger sample size of 100. It may not still be exactly, but the more trials you do, the more likely it will be close to the theoretical probability. All right, let's practice. Choose a random number between 1 and 25. What is the probability that that is an even number? So out of 1 to 25, there's a possible 25 numbers, and there are 12 of them that are even. So our probability is 12 out of 25, which is 48%. Now choose a random number between 1 and 20. What is the probability that that random number is greater than 5 and less than 15? So our total number of trials or possible outcomes is 20, and there are 9 digits that fall into this category of greater than 5 and less than 15. So our probability is 9 out of 20, which is 45%. Next, let's find the probability of selecting the letter C from the word mathematics. So imagine if we wrote out the word mathematics and we tore up the letters, one letter per piece of paper, and then we randomly selected the letters. What is the probability that we would select a C from the grouping of the letters? Well, there's one C in the word out of a possible 11 letters, and so we would have a probability of 1 out of 11, which is 9%. Doing the same for the probability of selecting a B from the word probability and doing the same experiment, our probability would be a 2 because there are 2 B's out of 11 letters. So for this one, we would get a 2 out of 11 or 18%. All right, let's see this in the real world. So Coach Taylor is working on making his batting lineup for an upcoming baseball tournament. It's going to use some probability here. He's trying to determine where to place Jake in his batting lineup, who has a batting average of 0.250. If he gets 16 at-bats over the weekend, predict how many hits he will get. So using his batting average of 0.25 and imagining how many at-bats he's going to get, 16, that would give him 4 hits at that average. So he would get 4 hits over the weekend out of 16 at bats. All right. You randomly draw a marble from a bag of 150 marbles. You record its color, then replace the marble. Use the results that you recorded to estimate the number of marbles in the bag for each color. You select a green, replace it, and you've done this trial, and you've selected 2 greens, 12 oranges, and 6 blues. So let's find how many trials did you complete. So you've done 2 plus 12 plus 6. That gives us 20 trials that you completed. And we want to use that information to predict how many marbles are in each color marbles are in the bag of 150. So we can do this with proportions. We've selected 2 greens out of a possible 20 trials, and that gives us 15 out of 150 in the bag. So we can use that prediction of 2 out of 20. We can probably estimate that there are about 15 marbles in the bag. We can do this for orange with a 12 out of 20, which means there's probably a greater number of oranges. Using a proportion, we find that there are likely 90 orange marbles, and same with blue. 6 out of 20 gives us a proportion of 45 out of 150. All right, thanks for watching. I hope you can find simple probability now.